With more than 100 impressive projects received from more than 20 countries, the Nemetschek Engineering User Contest is once again proving a huge success. 3 selected client projects from the contest provide impressive proof of the performance capacity of Allplan Engineering. The first example features the Anchor Plaza office building in Bucharest. The engineering firm Biro de Structuri SRL of Bucharest in Romania used Allplan Engineering to carry out the planning of the load-bearing structure. Anchor Plaza is a 99-meter-high office building with 27 floors and a gross floor area of 75,000 square meters. The composite steel load-bearing structure stands on a foundation slab 2 meters thick, mounted on board piles 30 meters long and 1.2 meters thick. The reinforcement drawings for the heavily reinforced steel concrete can be worked on with best possible results using the bar-shaped pallet and the improved workflow in Allplan 2012. In this case, the reinforcement is produced step by step. The graphic representation of the reinforcement and the labeling takes place later. And to do that, the label checkboxes in the input options of the bar shape and place bar shape pallets must be cleared. Following the defining of the bar shape, the placement process starts immediately. The automatic shell edge recognition, together with the angle halving hook and the automatic placement, allows you to define the reinforcement parameters to progress steadily, even in the most complicated situations. Thanks to the use of property palettes, the workflow can be designed in a more fluid and more intuitive way. The inputs carried out can be seen immediately, without the need for confirmation with OK. And any erroneous inputs can be easily identified and corrected. This is what Biro de Structuri had to say. It really is a great help to be able to see the connections in Allplan, particularly with regard to load-bearing structures made of steel and reinforced concrete. This helps identify potential conflict situations before construction begins. The second example client project is the Gotthard Base Tunnel. The section involved is between Erstfeld and Bodio. Gahler and Partner AG from Switzerland, an engineering consortium working on the Gotthard Base Tunnel North, are carrying out the integrated construction planning using Allplan Engineering. With 57 kilometers, the Gotthard Base Tunnel is the longest railway tunnel in the world. Construction began in 1996 with an anticipated completion time of 20 years. Construction costs amount to about 9 billion euros. The tunnel is overlaid by up to 2,400 meters of fault and fracture zones with exceptionally severe stresses imposed. For standard reinforcement situations, Gahler and Partner opted for the use of 2D formwork with 3D reinforcement, in which the 3D reinforcement is produced in a 2D drawing. In the more difficult areas, the firm made use of the 3D formwork with the 3D reinforcement method, with the 3D reinforcement being produced in the derived stages. Gahler and Partner AG had this to say: "Despite standardization, we have produced a total of about 120 different block plans and more than 1,000 drawings. It's a huge amount of data, but Allplan is handling it with no trouble at all." The third example client project is a branch of the Rabobank in Roermond, which involved the engineering firm Van der Werf en Naas from Maastricht in the Netherlands. With this project too, the planning for the load-bearing structure was carried out with Allplan Engineering. The shape of the building resembles a snake with its head raised. The architectural firm Engelmann was inspired by a sculpture by the artist Isamu Noguchi. Construction was carried out with cast-in-situ concrete in the basement story and prefabricated component construction for the upper stories. For the formwork, reinforcement, and production planning, Allplan 2012 provides an impressive repertoire of built-in components, ranging from a joining and fixing system from Anahuta and Erico Lenton for reinforcement planning, to Allplan built-in components and custom components. The range of manufacturers supported includes products from Halfen Deha, such as Halfen rails, punch perforation reinforcement, and ball head transport anchor elements, as well as Peco with its anchor plates, punch perforation reinforcement, and connections in prefabricated component construction, and Schuck with its famous Isocorb heat-insulating load-bearing elements. Philip have also been taken on board with a new range of threaded transport anchors, compact anchors, and transverse hole sleeves. All the built-in components used in the project are represented in the appropriate views and sections, and can be labeled in that format. And of course, it saves a great deal of time if the components can be evaluated in a report. The report provides a number of different filter possibilities with which a choice can be made between point, linear, and surface components. Additional information about the length or area of linear and surface components is included. Not only built-in components, but also prefabricated parts can be evaluated as user-defined elements. The exact volume of complex elements and the total volume of all the structural elements are shown in reports, as well as in the graphics of components. The engineering firm Van der Werf & Naas had this to say: "Not only the drawings were derived from the building model, as this also proved to be the ideal tool for deciding on the most practical sequence for assembly."